Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the earlier sessions, we were talking about various components of time series analysis. Number 1, secular trend. Number 2, seasonal variations. Number 3, cyclical fluctuations. Number 4, irregular variations. As continuation of that study, we have done some problems in secular trend by freehand method, method of semi-averages, method of least squares, and in continuation with that, in this session we are going to talk about seasonal variations, which is one of the component of time series. Basically, what is meant by seasonal variations? Seasonal variations are those periodic movements in business activity which occur regularly every year and have their origin in the nature of the year itself. That is, changes within the year are said to be seasonal. If the data is given in terms of annual, then seasonal variations does not play any role there. Since these variations repeat during a period of 12 months, they can be predicted fairly accurately. How to measure the seasonal variations? One of the method for calculating seasonal variations is method of simple averages. How to deal with this method? The steps are discussed here. This is the simplest method of obtaining a seasonal index. The following steps are necessary for calculating the index. Step 1. Average the unadjusted data by years and months or quarters if quarterly data are given. So, first of all, you have to adjust the data if it is not adjusted in the given case. Then find totals of each quarter. For example, if it is expressed in terms of month, then find totals of January, February, March, April, like that. Step 3. Divide each total by the number of years for which data are given. For example, if we are given monthly data for 5 years, then we shall first obtain total for each month for 5 years and divide each total by 5 to obtain an average, that is monthly average. After obtaining the average, obtain an average of each monthly averages, that is average of averages, by dividing the total of monthly averages by 12 if the data is expressed in terms of months. If it is expressed in terms of quarters, then you have to divide the quarterly averages by 4, whatever it may be, whatever the averages you have calculated, that averages of average you have to calculate. Next, taking the average of monthly averages as 100, compute the percentage of various monthly averages as follows. That is the seasonal index. So, seasonal index for a particular month January is equal to, seasonal index for January is monthly average for January divided by average of monthly averages into 100. Similarly, if it is expressed in quarter, then quarterly average for first quarter divided by average of quarterly averages into 100. That is how seasonal index is calculated by the method of simple averages. If instead of the average of each month, the total of each month are obtained, we will get the same result. That is, instead of using the averages, if we are using the totals, then also we will get the seasonal index answer to be same. This is another illustration where to find out the seasonal variation by the method of simple averages. And now if you see the values are given in terms of 12 months. Okay. So, consumption of monthly electric power in millions of kilowatt hours for street lighting in one of the states in India during the year 2006 to 2010 is given below. For the year 2006, the values are for the month of January, the street lighting consumption is 318 million kilowatt hours. Similarly, for the month of February, it is 281 million kilowatt hours. 278, 250 for the month of April, 231 for the month of May, 216 for the month of June, 223 for July, 245 for August, 269 for September, 302 for the month of October, 325 for the month of November, likewise and 347 for the month of December. Similarly, the values for the year 2007, 2008, 2009 up to 2010 is being given. Okay. So, the question is find out the seasonal variations by the method of monthly averages. Computation of seasonal index by the method of monthly averages. Whatever the values in the given in the question, just write it in this format. That is, the months are written vertically, corresponding to the years which I have read out now are written for the year 2006, and then for the year 2007 it is written like this, and 2008 the values are written from 367 to 394, and for the year 2009 the values are written from 392 to 389, and for the year 2010 the values are written from 420 to 422. Okay. So, the monthly total for 5 years. So, whatever be the format given, first of all write it in this format so that we get the monthly total, that is January total particularly for the 5 years, that is January 2006 total, January 2007 total, like that up to January 2010 total. So, this total 318 plus 342 plus 367 plus 392 plus 420 gives you 1839, and this total is obtained by adding 5 years, isn't it? 5 years, that is 2006 is 1 year, 2007 is 2nd year, 2008 is 3rd year, 2009 is 4th year, and 2010 is 5th year. So, this particular total 1839 is obtained by adding 5 values. So, if you want to take average, that total has to be divided by 5 number of years, that is 5 yearly averages is 1839 divided by 5 gives you this value. This value here is 1839 by 5 is equal to 367.8. Okay. Just hold the value of 116.1, how it is calculated, let me tell you next. Likewise, for the month of February 1645 is obtained by adding 281 plus 309 plus 328 plus 349 plus 378, and this value 329 is obtained by dividing this 5 yearly total by 5, that is 1645 is obtained by adding 5 values. So, divided by 5 you get 329. Okay. Next, just take the total of this 19,002, this is total of the totals, isn't it? 1839, starting from 1839 when the values are added and we get 19,002, and similarly just take the total of these 5 yearly averages. The total comes to be, that is starting from 367.8, 367.8 plus 329 plus 321.8, like that. If you just take the total comes to be equal to 3800.4. Okay. This 3800.4 is obtained by adding how many values? How many values? There are 12 values, January, starting from January to December. So, this 3800.4 is the summation of 12 values, right, 367.8 plus 329, like that these 12 values are added and we got the total as 3800.4. So, how will you get this 316? Next you have to find out the average corresponding to 5 yearly averages, that is 3800.4. So, this 316.7 is obtained by dividing 3800.4 by 12, which is equal to 316.7. Then how the seasonal index, this is what is the percentage. The seasonal index is 116.1 for the month of January and 103.9 for the month of February, 101.6 for the month of March, like that, and its total is 1200, and if you take its average it should be 100. This 116.1 is calculated by taking 367.8 divided by 316.7 into 100. That is what is the formula, right? We have seen a monthly average for January divided by average of monthly averages into 100. 367.8 by 316.7 into 100 is equal to 116.1 for January. Okay. Similarly, for February, I will just do for 2 months, then it is similar for the other months also. 329 by 316.7 into 100 gives you 103.9. Likewise, the values are calculated. These particular values 116.1, 103.9 are called the seasonal variations. After discussing about method of simple averages, the next method to find out seasonal fluctuations are ratio to trend method. So, the steps in the computation of seasonal index by this method are: trend values first of all are obtained by applying the method of least squares. Method of least squares, among the methods for calculating trend, method of least squares is very important and gives you some type of accurate values. So, trend values are obtained by applying the method of least square. The next step is to divide the original data month by month by the corresponding trend values and to multiply these ratios by 100 to get it in the format of a percentage. The values so obtained are now free from trend, and the problem that remains is to free them from irregular and cyclical movements, so that we get the seasonal index. Okay. That is also one of the method of calculating seasonal variations. That is, in the multiplicative model TSCI, trend is calculated and eliminated. That is why it is being divided. So, there remains SCI, and when the case itself is such that cyclical and irregular movements are free for that particular case, then there remains only seasonal fluctuations. In order to free the values from irregular and cyclical movements, the figures given for the various years of January, February, etc. are averaged with any one of the usual methods of central values, that is either by arithmetic mean method or by geometric mean method or by mode method, like that. There are various methods for calculating the averages. For instance, the median or the mean. If the data are examined month by month, it is sometimes possible to ascribe a definite cause to usually high or low values. Next, the seasonal index for each month is expressed as a percentage of the average month. The sum of 12 values must equal 1200 or 100%. If it does not, adjustment is made by multiplying each index by a suitable factor. This gives final suitable seasonal index. Now, after discussing one of the problem in seasonal variation, the next problem is finding seasonal variations by ratio to trend method from the data given below. So, the year is again 2006 to 2010, first quarter values 30, second quarter is 40, that is the whole 2006, whatever by the years, the whole year of 12 months is divided into 4 quarters. Okay. Then third quarter is 36, fourth quarter is 34. Like that, the values are given from 2006 to 2010. For determining seasonal variation by ratio to trend method, first we shall determine the trend of yearly data and then convert it to quarterly data. So, first of all, we have to calculate the trend values. What is the method to calculate trend values? Method of least squares. How do we calculate method of least squares? Trend equation. Y is equal to A plus Bx. We have to calculate the value of A and B. Okay. For that we need the year values. Just recall how the trend values are calculated. We have done some problems in the previous session. Trend values will be calculated only if the data is given in terms of year and the corresponding yearly values. So, that has to be noted. Calculating trend by method of least squares. So, this 140 is yearly total, which is nothing but the first quarter total plus second quarter total plus third quarter total plus fourth quarter total, that is 30 plus 40 plus 36 plus 34. Similarly, 180 is obtained by adding all the 4 quarter values in 2007. So, like that this has been written, and yearly average y. After that we have to convert it for average. Yearly average y is divided by 4, because 140 is obtained by adding 4 values. So, 140 by 4 is equal to 35, 180 by 4 is equal to 45, similarly 200 by 4 is equal to 50, like that, and yearly averages is total of summation y is equal to 35 plus 45 plus 50 plus 65 plus 85 gives you 280. Then for the calculation purpose, the year value, years 2006, 2007 has to be converted to x values using one of the year as the middle year. Since 5 values are given, we can take 2008 as the middle year, and 0 is given against 2008 because the deviations are from the mid year. The mid year here is 2008. So, this value, particular value is 2006 minus 2008 is minus 2, 2007 minus 2008 is minus 1. So, like that 0, 1, 2. Then calculate x into y. X into y is minus 2 into 35 minus 70 minus 1 into 45 minus 45, like that these x values and y values are calculated, and take the summation of that. Summation y is 280, summation x should be 0, so that we use the direct formula for trend. Summation xy is equal to 120, summation x square is 10, and these are the trend values. How this 32, 44, 56, 68, 80 are calculated? The equation for the straight line trend is y is equal to a plus bx. Since summation x is equal to 0, a is equal to summation y divided by n. What is summation y? Summation y is these values, 280 divided by 5 is equal to 56. This is the direct formula when summation x is equal to 0. Then summation xy by summation x square is 120 by 10 is equal to 12. This 12 b value represent annual increment, okay, from 2006 to 2007. So, for quarterly increment it has to be divided by 4. So, 12 by 4 is equal to 3. First of all, the trend equation is y is equal to 56 plus 12x. This is not going to help you for finding trend values. In this case is been given in terms of quarter, therefore, we have to use quarterly increment only, that is quarterly increment is 12 divided by 4 is equal to 3. Calculation of quarterly trend values. Consider the year 2006. Trend value for the middle quarter, that is half of second and half of third, is 32. Quarterly increment is 3. So, the trend value of second quarter is 32 minus 3 by 2, and that is 30.5, and for third quarter it is 32 plus 3 by 2. After finding the quarterly increment as 3, The calculation for quarterly trend values is done like this. Trend value for the middle quarter, that is middle quarter is between second quarter and third quarter. Actually this 32 will not be displayed, the 32 comes somewhere between second quarter and third quarter, this is 32 here. Okay. Since the quarterly increment is totally 3, this is middle of second and third quarter, right. Therefore, for finding the value corresponding to second quarter, it should be 32 minus the quarterly increment is 3, and here this 32 is halfway between second and third quarter. It is like a 2.5 quarter, like that. So, 32 minus 3 by 2. 32 minus 3 by 2 gives you 30.5. Similarly, if you want for the third quarter, this is 2.5 quarter, right, and the quarterly increment is 3. So, from 2.5 quarters to third quarter, it will be 3 by 2 is the quarterly increment. So, 32 plus 3 by 2 gives you 33.5. Now, we will not calculate its 27.5 first of all. We will calculate this 32 first, which is half of the second and third quarter. Okay, half of second and third quarter. Then we calculate 32 minus 3 by 2 is 30.5. Then we calculate 32 plus 3 by 2, we calculate 33.5. Okay. Actually this 32 is not displayed, 30.5 corresponding to second quarter and 33.5 corresponding to third quarter has been displayed. Since the quarterly increment, that is why we have calculated the trend equation. Corresponding to the first quarter, since the quarterly increment is 3, for obtaining the value for first quarter from second quarter, it is 30.5 minus 3 gives you 27.5. Similarly, after 33.5 is written for the third quarter correspondingly, for the fourth quarter we have to add the quarterly increment of 3 to third quarter to obtain fourth quarter. Okay. So, 33.5 plus 3 is equal to 36.5. Okay. So, similarly, these values are also calculated. Here this value here is 44 and that is half of second and third quarter. Therefore, here you will have 44 minus 1.5. 1.5 is 3 by 2. 44 minus 1.5 is 42.5 and 44 plus 1.5 is 45.5. 45.5 plus 3 because quarterly increment from third quarter to fourth quarter is 48.5 and 42.5 minus 3 is 39.5. Likewise, the values are calculated. First of all, calculating is 32, 44, 56 and then here if you take it is 68 and if you take here it is 80. These values are important, that is the values in between second quarter and third quarter. Now, after the trend values are calculated in terms of quarters, then we go ahead for calculating seasonal index. Quarterly values as percentage of trend values. Okay. Just take this particular box corresponding to the year 2006, the first quarter is 27.5. Therefore, the corresponding values given in the question is 30. So, remember corresponding to the year 2006 for the first quarter, the original values given is 30 and trend values calculated are 27.5. So, this 109.1 is obtained as the question value 30 divided by 27.5 into 100. Okay. This gives you 109.1. Similarly, for the second quarter 131.1, this is 40 divided by 40 is given the question and divided by 30.5 into 100 is 131.1. And then next this is 107.5 is similarly 36 by 33.5 into 100 is equal to 107.5, and corresponding to the fourth quarter, this is 34 by 36.5 into 100 is 93.1. Okay. Similarly, the average values for the year 2007 is calculated. First of all, total of these values of 109.1 plus 86.1 plus 85 plus 106 is 463.9, and divided by 5 we get 92.78, and 92.78 is adjusted as 92 to get the total as 403.08 total of averages. Then similarly, the total is 591.3, divided by 5 you get 118.26. Likewise, it is calculated 92.78 plus 118.26, that is total of the averages. Here the total is 403.08, average of averages is 403.08 divided by 400, that is equal to 100.77. So, seasonal index is adjusted value 92 is obtained as 92.78 by 100.7, and similarly total is more than 100 and adjustment is made by multiplying, because the total here is 403.08. So, if it is more than 100, this kind of adjustment, seasonal index adjustment has to be done, otherwise this is the answer 92.78, 118.26, 102.92, 89.12. This is the answer. Since the total comes to be 403, which is 403.08, it has to be adjusted. Therefore, the adjustment is divided by 400, you get 100.7, and adjusted value is 92.78 by 100.77 into 100 gives you 92. In this session, after discussing the basics of seasonal variations, we have worked out some examples in finding out seasonal index values. That is, first method we followed is method of simple averages, and then ratio to trend method is followed. That is, using method of simple averages we calculated simple averages, and using the method of ratio to trend we calculated seasonal index. Thank you.